Welcome, everyone. I hope you're doing well. Thank you very much for joining us today. My name is Anna, and I am Senior Marketing Specialist at the University of Tartu. And I'm very happy to welcome you to the Alumni Talks 2023. Alumni Talks is our new series where our fantastic alumni share their stories of studying at the University of Tartu, and also give a short lecture on a topic they chose. Today with me, I have Savio, who graduated master's program in robotics and computer engineering, and now he is a junior researcher fellow at Tartu Observatory. He's also pursuing his doctoral degree in the design and development of space missions. Savio was also a member of International Student Ambassadors for 3 years, and I was working directly with him, and he was also, the last year, he was an event manager, so he was also organizing event for the student community. Today's his topic will be advancing robotics and space technology towards terrestrial and extraterrestrial exploration. Before we begin, before I give a floor to Savio, I would like to mention a few details. So if you would like to leave your questions at any point during this webinar, please do so. You can do that under the Q&A section. So once we receive your questions, we're not going to answer them immediately. We are going to wait until Savio will finish his talk, and then at the end of the webinar, we are going to open Q&A session and we are going to answer your questions. Also, if you have any technical issues, please let us know. We are going to try to resolve them as soon as we can. It is also worth to mention that this webinar is recorded, so you are going to receive recording after the webinar is done. And I guess that would be it from my side, and I would like to give a floor to Savio, who is going to have his talk right now. The floor is yours.
All right, thank you very much. Let me try sharing my screen. Yes. Yeah, I'm probably too old for all this already now. So is it
yes, we can see the full screen. Yes,
the full screen?
Perfect. Yeah.
Right. Potentially, and now it should be in the presenter view. Just a moment. Sorry. Yeah.
We started the presenter view, so we could have seen your full screen.
Yeah, it should work now.
Yeah, this works.
Okay, great. So, all right. Well, thank you for inviting me for this talk. University of Tartu and Marketing Office. It's a pleasure to be here and to talk something about what I've been doing. Also, how have I been doing it in the context of my research, and also how has the master's program actually helped me. So welcome to this talk for all those who are joining from different places, hopefully late night for you guys or early mornings. I'll try to keep it nice, short, brief, and hopefully exciting for you guys to take back something. So yeah, this talk is on a quite mouthful of a topic, but it's quite relevant on what I've been doing and what potentially also is the requirement for global needs. And before we begin, Anna was kind enough to introduce me, so not a very relevant slide, but sure. My name is Aditya Savio Paul. I have a bachelor's degree in mechatronics engineering. Feel already old enough, having graduated in 2017, and I completed my Master's of Science in Robotics and Computer Engineering here in Estonia at the University of Tartu with Robotics and Computer Engineering program. And now currently I work at Tartu Observatory as a junior research fellow and working on the designing of space missions, which is also in parallel with my PhD study, which yeah, is always a task, but is always fun to do both in parallel. Apart from academics, and when it comes to interests, I've been since Estonia is quite a scenic place, I've been enjoying hiking and doing other sporting activities which I've not done before. Also a bit of writing in blogs and other short posts, but also enjoying something that I've always loved is playing cricket here. Now, before we dive into this world of big exploration words and how robotics and space technology is trying to help us get through them, probably it's good to investigate on a little distinctions that prevail. So robotics is, and these are of course my thoughts, but also hopefully are also correct, but mostly people understand them as they are, where robotics is enabling these robots to sort of help us and perform tasks that usually humans are either too lazy or it's too dangerous for them. And at the same time, space technologies to enable such technologies which we can explore the space around us. Robotics and space technology both work in challenging environments, as we know about it. Robotics is mostly with environments which are dangerous to humans, and space is a dangerous place for humans to be. And so both of these are quite concurrent with their goals of what they help us with. And yeah, of course, assisting humans with robots, it's easier to do very difficult tasks, pick up very heavy items, move from one place to the other. With space technology as well, the main goal is that we can actually go further than where we are, and using such technologies which can assist humans. And with robotics, it's mostly the attribute of using elements and agents which are quite heterogeneous or different in their actions. We have vehicles or robots that move on the ground, move in the air, move on water, sometimes underwater. And the similar thing with agents when we come to space technology or machines that are helping us go beyond the realms of the Earth, rockets, spacecrafts, rovers. So it's interesting that we somehow started on finding distinctions between robotics and space technology, but eventually we see with these 4 points and many other which have not been listed but are quite prominent, that both of these technologies and domains are actually helping us to understand the spaces around us. They are quite unique in their own domains, but quite similar when it comes to expanding human information and human cognizance towards different places and more different challenging environments. And the global sort of direction is to use such domain-specific knowledge when it comes to applying robotics or applying space technology and combining them in a new word called space robotics, but all in all with the single goal to advance technology and these exploration techniques. And so as to move on, would probably be nice also to discuss what has been my personal motivation to explore what's out there and why have I been pursuing it. So yeah, it's always curiosity, which is a natural psychology for all humans to be driven by it when it comes to learning something new or just being quite inquisitive about what new would be there. And for me, it was the same, but it came mostly with all the challenges that are posed by space exploration, and just the idea of how rockets fly, or how can we move rovers on Mars, or how can we fly to the moon. These were the challenges that kept my curiosity fueled and motivated me to pursue something like this. And I've always been interested in space exploration, but it was always the curiosity that helped me to move further. And based on these curiosities and the unknowing of how to do it was where I would look out and seek for opportunities of how do I grow my domain knowledge? How do I think of how engineers and scientists have made it possible for us to move outside the realms of the Earth, and potentially also now with spacecraft going outside the solar system and continuously communicating with us still. These are all technological marvels that I would like to know more about, and hence always on the lookout for opportunities that help to advance my domain knowledge. But all in all, as it is a personal motivation, it is also something that is shared by all, is to have an improved understanding of what surrounds us, what is space, and what can we do with it? Could we even go further? It's all these that personally motivate me to have pursued this. And a few points about this image, which was particularly one of the very first ones I must have seen, at least since I consciously remember, is the pale blue dot, where the image was clicked by a spacecraft, which is now outside the solar system or the known solar system, and it clicked a photo of the Earth. And basically, that's all where all our information and consciousness is, and potentially the goal would be to expand this consciousness into knowing the space around us. And the global motivation, which is quite relevant around us, and also perhaps fuels many other researchers and scientists, is the challenges that come across when we have to explore the spaces around us. This comes in play when we are talking about even terrestrial challenges or extraterrestrial. Both, as we discussed before, have the potential to share some similarities, but also are quite unique in their own way. But nonetheless, when it comes to terrestrial challenges, we have quite many explored regions here on Earth as well, which may be dangerous for humans or may not. But there are chances that we have never been there, and we may never be able to go there if based on our own human capabilities, and that's where the challenge of exploration comes in. Apart from that, there are also these natural calamities that are quite frequent here on Earth, and also cause a havoc around the ecosystem near them, or they can be either natural with the bushfires, for example, in Australia, or dams collapsing under the influence of the rivers, which can be potentially hazardous for the villages around them. And the effects and casualties of these are quite harsh, and studying them in the terrestrial context is quite important. But not only are these relevant in the terrestrial context, but also in the extraterrestrial places where there are still unexplored regions which may be dangerous for humans. A lot of weathering effects happen on surfaces of Mars. For example, in this image, you see are two different photographs of the same place at different times. And on the right-hand side, there's a huge sandstorm that hit the rovers which were on Mars. So for humans who are trying to be species of interplanetary descent, could also learn from a lot of these terrestrial and extraterrestrial challenges of what could come their way if not thought about before. And the main motivation is how to mitigate these, or even how to avoid them, and that's way more important than just trying to explore the space. Knowing what dangers lie ahead are also quite important. And just to point out the challenges which lie within the terrestrial and the extraterrestrial sort of applications here, as we call it, there are quite rugged and undulated landscapes, which of course are quite known in the hills, or even underwater are quite dangerous environments. And so is it in the extraterrestrial places as well, where we do not know much about the terrain or the geology or what kind of environment exists. It's all the same when it comes to here on Earth or on different planets. As we talked about, a lot of seasons and natural calamities which sort of affect the ecosystem around, whereas even on different planets there are a lot of weathering and atmospheric changes which can be quite harmful if ever humans went there, or even for robots which are on different planets. On Earth, of course, there's a big cause of us overutilizing the resources, but the main aim is to know their use case and how are we effectively using them. And the same also applies in when we move out to different planets of how we can use the resources available there to advance human exploration, or also if it in return helps in human establishment. For example, this on the image on the left in grayscale is basically the image clicked on the surface of a comet with one of the missions that went and captured the surface images. And very similar features with the comet can also be seen here on Earth with the mountain tops, very similar features, which gives us an idea that what's out there is also quite evidently available here on Earth for us to test our technologies and also to plan missions where we could actually explore something out there by testing what is here on Earth. And similar study can also be seen in these two images. The one on the left is a radar map of volcano here on Earth. I believe it's in Ethiopia, and on the right the images of a radar image scan of a volcano on Venus. So very similar features were observed, and this helps us to understand more about the features and terrains on other planets, very similar to what exists here on Earth. And this helps us to realize that the challenges that have been posed by space exploration are quite similar to the challenges which are here on Earth. So since we are a part of space ourselves, it's quite important that we should also make efforts to learn what's around us and then try to move forward. But for me, the roadmap to learn these challenges, of course, didn't come naturally. There were quite many. Of course, I didn't know many of these challenges before I did my master's. But other than that, quite many resources were already available. We have books that relay a lot of information, a lot of online resources that could be helpful. Would have been helpful. Just simple employment in companies which are working with robotics and space exploration is always a positive to learn and apply. But for me, still talking about my motivation to pursue such learning, I found myself to be looking at opportunities where I could learn more such information and gather such information through more structured learning. And fortunately, I found the robotics and computer engineering program at University of Tartu to help me sort of envision what I would like to learn. And more importantly, of course, a lot of what's there on this slide is useful to me still. But what I was also looking out for is the constant learning, structured learning, which would have helped me to learn a lot about these challenges. The community that I would get with people who are thinking about the same challenges, or for example, like-minded people who are working on missions that actually help in human understanding of potentially other planets and asteroids or comets. There are a lot of peer networking to be able to meet up with people in person, or just to be in a community that would actually talk about the problems and the learnings and potential solutions that I could actively learn. So that was one of the motivations of me planning to move on for a master's in such a program. But talking more about what I've been doing ever since I joined the university, started right exactly after I joined master's. So there was a lot of learning that came in quite quickly, which was quite nice, and that's what I've been working with for quite some time of my master's, and now continuing with my research is on the design and development of space missions, which mostly deals with the sort of understanding the environment around us and how do these events change over time, how are the environments very dynamic, and how can I learn more about events that happen either on the surface, perhaps volcanoes that may be erupting, or geysers that erupt sometimes at odd times or quite regularly, and how does that activity help any of us understanding the environment, and also things that we can't really see is the gravity. So potentially, how can we map gravity, for example, for asteroids and comets, and how do we know what can we do with that information? Of course, a lot of this is involved with designing missions which use these opportunities that come perhaps once in a lifetime. For example, an asteroid coming very close to the Earth, which would be a good time for us to study, hopefully not crashing in, but definitely a good time to study such targets and also be able to mitigate or avoid any catastrophes that may come across. So they could be comets or asteroids or planetoids, which are more dangerous to the Earth, and we might know more about them. But more about it is also not only just pursuing what is the study about knowing the environment or designing missions, but developing these capabilities and technologies which are not only useful here on Earth, but also all the learning can be transferred when we go out in space. So a lot of these technical solutions should and could be relevant while we are solving problems here on Earth. And when we go out to be interplanetary or go out to other places, then a lot of these solutions tend to have a positive effect when the technologies are just transferred or the learning is transferred. Just to go briefly over the research directions, which are my personal motivation, and as well as working with the labs, is something to know about environments, and in this case, a little about 3D reconstruction, where we try to observe a particular object or a particular target from different positions in space. And in this image, it's more about cameras. And a very good example came about in 2021 when a smaller volcano erupted in Iceland, and that proved to be a good sort of experiment for me to understand what may be going on with such an example of a surface activity. Of course, it was quite a casual one. It wasn't very catastrophic. People were all around the volcano. I heard they were barbecuing and all the fun stuff. But of course, from the science perspective, it was really nice, where I could gather the footage from drones around the volcano, and some of the images that people clicked as well. And I could use those images to form something which is called a digital model of the entire event. And here you see in this video is quite what's similar that we would achieve when I performed the 3D reconstruction. And I could just pause the video here to show you how interestingly we also obtained the flow of the lava and some other features that were developed. How would the shadows be informed, and things like that could help us understand this activity a little more deeply in case of an event which would perhaps be catastrophic. So we could learn how the lava would flow if a bigger volcano would erupt or simulate such kind of scenarios, and maybe help in some sort of mitigation or evacuation well within time. Yeah, so similarly, what was done with the volcano was also pursued with an object in space where multiple spacecrafts were positioned. This is, of course, simulation. And an asteroid, or in this case, a recent event where a very long sort of body passed by the Earth with very little information. And having observed it from different places by different spacecrafts, you could digitally reconstruct it by using frames from different spacecraft. So over here, we were able to achieve quite a close distinction of what the object could have been if you'd have been able to place spacecrafts in between. So this gives us the sort of proof of concept of study that if at all such an event happens again, and if we are able to position our spacecrafts in a very in a place that is scientifically feasible to perform such study, then we should be able to get some more information, perhaps about the surface and what's the color and what's the density and things like that. Right. And with robotics, one of the challenges is to move from one place to the other while avoiding obstacles and not colliding in obstacles that come around. And a lot of techniques have been developed that help in pursuing it, where we use a start point and a goal point, define the obstacles, and then we sort of move on the trajectories that are possible. And this is quite easy now. It's state of the art when it comes to ground robotics or even aerial robotics using ground vehicles or drones. But I also took this step a little forward and tried to do the same thing when it comes to space. Of course, it was a nice way to add on to the spacey things. And when we refactor some of the elements from these robotic research and apply it in the space context, right, then we may be able to achieve something which is quite similar but quite useful in both the terrestrial and the extraterrestrial extent. So in this case, the same trajectories are explored when we have to pass by an asteroid while studying it. So making sure that we don't crash into it, very similar to our research with the robotics platform, not to collide into the obstacles, but in the space context, pass by at such a safe distance where you can also study it. So this was the transfer learning that also was quite useful when I was developing my master's thesis at the university, and it was a part of the thesis plan as well. Right, and very similar to the work with the trajectory plan. Once we have a very safe trajectory, it is also possible to do other scientific experiments. For example, in this case, I also mapped the gravity of the body that we actually passed by. These are just examples to show how, for a given asteroid, the gravity map can be very, very non-uniform, which means that one place it would be a very high gravity and the other place it would be a very low gravity influence. So part of the study where we research on environments that are very dynamic, it is important that we are able to map them with some form of accuracy. And in this study, with the same safe trajectory planning, I was also able to achieve orbiting around an asteroid, of course, in simulation. This mission isn't launched, and I hope it is launched one day, but with good hopes. But in this case, the spacecraft starts with a very low knowledge about the asteroid's gravity field, and as it keeps orbiting, it knows more details about the gravity field, and the trajectory becomes smoother with time. The red means that it is still at a dangerous place, or the gravity is too high for it to be quite close. And what happens on board when the gravity is planned is the spacecraft moves around. It is similar to the map above, and the gravity starts to be made more known, where the yellow part is where the gravity is the highest. So the top one talks more about the safe trajectories, and the below one talks about how we are able to know more about the environment that we are actually moving in. So a lot of the research that I've spoken about is quite similar in its way, that we are not only just learning more about techniques that are useful here on Earth, but also when it comes to space, and we are able to map our environments quite efficiently using such techniques with just minor and modern applications of refactoring of what is required when it comes to the researching on Earth and when it comes to researching outside in space. But for all these tests, as we've spoken about, that a lot of things which are here on Earth are also exist out in space on other planets. sometimes when we need to study a lot of outer planet features and geologies and terrains, then it's also important to somehow recreate what's present out there. And in this case, part of my research and with the Department of Space Technology at Tartu Observatory, we've also developed something which is called our Space Mission Simulation Center, which basically boasts about a lunar landscape that has been developed. And this is quite similar to features what would exist on the moon. And we could actually test all our robotic applications when it comes to which would be potentially useful when it comes to moving on the moon. And a lot of these hypotheses and scenarios can be tested in both the analog environment and the simulator that we have been developing in the at the observatory as well. Most of it, the learning comes from what I have been learning in the master's program, and a lot of applied knowledge is transferred here. So we can do a lot of moon-based simulations when it comes to either simulating how the sun would be, at what angles, and can we generate enough power from the solar panels, or how long would the traversals be if we need to move on the moon for about 2 to 3 days, and things like that. And along with the lunar surface, we also have a setup for what is called a comet flyby scenario, where we simulate the motion of a comet moving on a thin wire, but quite similar to how a comet would be when spacecrafts encounter it. So I can pause it here and show you, and it's a blurry image, but that's how potentially it would also be seen. And a lot of these techniques and practices in the analog environment are helpful to sort of verify our approaches, maybe validate some of the data that we've got, and even test some new techniques that that are potentially in development. Right, that's mostly coming to the end, but I would like to spend some time on the part of where I've been learning all of this. It's to the robotics and computer engineering program at the university. And for my jump from my bachelor's to master's has been quite interesting in a way that I got accustomed to a lot of courses that were completely new, but the structure in the university was so that it was quite modular, with very discrete divisions between mandatory subjects, specialization, and optional subjects. Of course, the mandatory ones are what lay the foundations to more learning and more organized learning, but the specialization and the optional courses were so that we could choose our own curriculum, of course, with the guidance of the faculty and the mentors and your supervisors here. But the students also had their freedom to choose their own direction of research. And for me, I found my specialization in space technology and a few courses which I took with computer engineering as well. And of course, optional were the fun courses, but also the ones which helped to learn maybe soft skills, or even giving presentations like these, which are quite important. Yeah, the credits, and it is of course a credit-based system. You need to accomplish a few credits, but I would say that it never felt like the credits were the most important part. I looked at the learnings, and the credits came automatically somehow as time progressed. The workload is nicely divided between assignments, projects, theory, and practical, and all of that helped with the common goal to actually achieve the desired goal of learning and applying something new. Of course, there were assessments in the end, but it was nicely structured that if you attend all lectures and assignments, then you will get all the credits you deserve. The main thing, which of course I've also illustrated before, is the community that I was looking out for, is to be able to talk to people and interact with people who have a common goal of solving problems in space technology and space exploration. But in the course of finding that, I also found myself interacting with a very international community here in Tartu, being a student town. Most of them were students, hence very academically oriented, but also very diverse, different backgrounds, different people, different experiences, and it was always a fun time learning about those experiences, more about what I could share, what I could learn from them, and of course the peers that came in with the program were always helpful in guiding you all the way through. Yeah, I was sort of lucky enough, and also to let others know that there are a lot of opportunities and scholarships that prevail. And of course, it requires some sort of hard work to achieve those, but they are not the only criteria to learn. They only help uh, to live comfortably, but the learning comes with your own motivation. And these are not the only things that help, but definitely are supportive in doing that. Of course, I enjoyed a lot of sports during my master's here. Learned new sports. Ice skating was new, skiing was new, and got better at sports which I already knew. Of course, the part which was the most important element of my master's thesis to actually present a thesis, but it never felt like a big burden because I've had enough practice before I even delivered it, a lot of feedback, and on different occasions in seminars, in talks, in with just sitting down with your supervisor and discussing, a lot of it was quite helpful in developing a decent thesis that could be presented eventually. Right, and yeah, mostly wrapping up, but of course, it's always good to illustrate on whatever I'm doing and whatever is a research plan is also globally not only just accepted, but also other people are also working in the same direction, and especially Estonia as a country moving towards being a frontier in robotics and space technology. We have technologies being developed which are potentially going to the moon. Rovers which are helping to regrow forests here on Earth are also being studied for exploring the moon, not potentially not to plant trees, but definitely all the other aspects of moving around in rugged or undulated environments. Hopefully the second student satellite from Estonia will be launched soon. It's known as the 2, which is also the project with which I started working in Estonia. And yeah, we have active research going on with imaging comets and developing space missions which can go to such places. And just to wrap up, a few images quite difficult to find now that I was building this presentation, but it's always good to go back in time and look at them as well. And I found a lot of innovation with simple messages when I was talking to people who were already here about 4 years, 5 years back, who didn't help me much with a lot of information what to do in Estonia, but just a simple message of saying that, yeah, we'll see you around in Tartu soon, just helped to take my decisions. A lot of new sports being learned with friends and yeah, with friends who came along the way. And yeah, as Anna mentioned, I also was a part of the student ambassadors program for about 3 years. Yeah, which was quite nice to be a part of, which was also a very important time of my master's, where I learned a lot of soft skills, sometimes hard skills, and team management, and even giving presentations like these was something that I became more confident. And of course, the thesis defense, which was always the crux of the master's. And that would probably be all from my side. To end, it was really great studying my master's here, and of course now I continue with my PhD. It's always a pleasure to be here. The Institute of Technology is where I learned all my technical know-hows and made good friends, and now I work here at Tartu Observatory. So for prospective students out there, if you're ever coming here, then we'll be happy to meet up. For people who are looking out, probably finishing studies and wanting to research, of course, happy to reach out and connect with them. But thank you so much for your time, and yeah, maybe we can move on.
Taking us through your journey of studying masters at the University of Tartu, and also talking about your research. And I also saw a picture of me somewhere there, so I'm glad that I was a part of your journey during your master's studies. So now I guess you can stop sharing your screen, and we can move to the question and answer sessions. We received some questions, so let's check them out. So the first question, did you have the same research during your master's? If yes, how did you develop it, I guess? Or did you change it for the PhD?
Yeah, so I would say that the main goal of learning how to explore space remained the same ever since master's and PhD. I was lucky enough that I got supervisors during my master's who guided me on topics which were quite relevant, not only during the time of like 2018 to 2020, but also sort of the questions became more complex as I moved on. And that helped me to develop it into a PhD study as well. Of course, with more complexity, more questions to be solved. But the skills that I did learn from my masters were in the same direction as I would do my PhD as well. So it's quite always nice to continue what you're motivated for. Yeah.
I guess the second question is also related to the first one. Did you have different directions in mind when choosing the topic you are currently working on?
Yeah, well, I would say when I started, I was all over the place. As a fresh master's student, you would like to do everything and anything, whatever feels nice to you. So that's when guidance from the supervisors and from people you talk to really comes into play, and you really understand that, okay, this is what I should be working on, and this is what is relevant. Sometimes it's very project based because a project requires it to be done. Sometimes it is very research based, where you identify the research gaps, and if that really helps you to identify what you would like to do, then it works great. So yes, there were many different directions, and it took time to choose the topic I would like to work on. But it was a very fruitful journey, that one as well.
Thank you. Let's move to the next question. Such an interesting talk. Do you need to speak to learn to speak Estonian at your job?
I would say that Estonian has never been a problem for me in Estonia. As I said, most of the people here are students, and it's a very international and vibrant culture. So Estonian has never been a blocker for me to learn or to speak. Of course, it is nice to know and understand the language of the place you're living in. It helps you to sometimes, order lunch or buy groceries. But it has never hindered me from learning anything new or talking at my department. And yeah, even the department here is very kind enough to converse and not enforce Estonian on us. Yeah.
Thank you very much. I guess two of the next questions are also quite similar. So first one, is it possible to do an internship at the Tartu Observatory? And the second one, are there any work internship opportunities in the observatory available for bachelor students?
Yeah, so of course, opportunities are always there for people who'd like to work and those who are also interested. So if you feel that you would like to work and think about doing an internship or learning something new, Tartu Observatory is also part of the University of Tartu. So it's very academic in its own sense. And please feel free to reach out. And yeah, all the projects that are listed are also currently active projects. So if you find anything useful, we can always discuss. And yeah. So yes, it is a possibility.
Did you have yourself any internship during your studies? And did you do that at Tartu Observatory or somewhere else?
Yeah, I was lucky enough to have had an opportunity to work with the SQ2 satellite when I was doing my master's, and that was the time when we were actually developing the satellite, and now it's on the prime of hopefully launching. So always a pleasure to see what you've been working on during your master's, be launched into space. So hopefully it serves as a motivation for others as well.
Next question. What were your favorite courses outside the curriculum?
Outside, well, I enjoyed the courses in the curriculum so well that I didn't have to take any courses outside.
I guess maybe it's meant like not compulsory courses, but like optional.
Okay, outside the mandatory. Yeah, well, I would say apart from the regular academic courses which are mandatory for me or for the program, I did take up courses which were like Estonian culture and program. That was one of the courses which I enjoyed a lot. Got to learn about a lot of Estonian literature, Estonian handicraft, and the local words and languages and how they interact with other languages. So it was a short course, but I really enjoyed doing it. So the Estonian language and culture course was quite nice.
Such a nice recommendation. Thank you.
Yeah.
Okay, next one is about admission. How did you prepare for the admissions? Do you have any tips?
Yeah, yeah, of course, the information on the websites is quite clear, so I didn't have as much problem accumulating all my documents which are required for the admission, but I did reach out to a few people, mostly who were actively working in the department and also at the university, and just asked them not very document specific questions, but more in general about life in Estonia and what would I need to be prepared for from. Perhaps I didn't mention, but I'm from India. So coming to Estonia was a completely new world for me, different type of cold, different seasons. So I think I was more interested in how I would be able to adjust. So yeah, doing well so far, I believe.
Adjusted, well adjusted. Oh, next question is related also to Estonia. Did you plan to stay in Estonia before started studying at the University of Tartu?
Well, there were no immediate plans at that moment that I would end up staying in Estonia. Of course, it's nice that I was able to get a PhD opportunity, and the department is quite helpful in helping me to accommodate here still. And I've got a very friendly environment to work with. So I don't know, is it still in plans that I would eventually end up staying in Estonia? But at this moment, I am staying in Estonia. So yeah, it's been fun so far.
Okay, next question. Thank you. What was expected and unexpected when you started studying at the University of Tartu?
Expected, of course, a lot of new information coming very soon, especially in the first year. So that's how I tried to structure my master's as well, to try to complete a lot of courses earlier in the first year so that I had enough time to do a good thesis, in my hope, in the final semester. Unexpected, I have always heard that yes, the cold can be quite harsh, but the first week when it was completely dark was not something that someone from my side of the world would expect so immediately. Took time, but I think the facilities which are here in Estonia are quite well suited for us to be able to tackle all of those. So wasn't as much as unexpected, but yeah, we were well prepared when it came.
It's good to be well prepared. Thank you.
Yeah.
Next one. Are you enjoying student life in Tartu? What would you recommend for future students about living in Tartu?
Yeah, I'm definitely enjoying the student life. It gives a lot of academic preferences, That's one of the things. You're always in an environment which is academic oriented. It's good for my PhD study and definitely very good for master's students. It's a quieter town, so there's not much disturbance if you're not a every night partying person, but once in a while is always good. Recommend to future students, I don't know, keep your vitamin D tablets with you at all times, especially during winters. That can be a little harsh for someone who's not coming from places that cold. But otherwise, yeah, go with the flow and try to learn as much as you can. I think that's the best recommendation. Try to be more vocal, and you'll always find good friends around you. Yeah.
Thank you. And next question. Thank you for an interesting talk. Did any of your course mates stay in Estonia as well and are now working in the same field?
Yes, indeed. I made quite friends during my master's. I think 2, 3 of them are still working and are doing a PhD. A very close friend of mine is working in the same field. So yeah, people have stayed back if that is the question answer person is looking out for. And indeed, the opportunities exist for you to continue studying or even working. There are quite many companies that work quite in parallel with the projects at the University of Tartu, so it's quite easy to try to seek for a job opportunity in the company. So yeah.
Thank you very much. Next question. Do you know what are the newest developments with S-Cube?
Well, yes, given that I gave a presentation in S-Cube a couple of hours before this this seminar, I do somehow know, of course, S-Cube is on S-Cube 2, if that's the question that the person is asking, is getting prepared to be launched. That would be a good sign for students at the university and as well as Estonia for having their second satellite in space. Yeah, there are other proposals which are being floating around as well. So yeah, if you're interested, then yeah, do feel free to reach out. And if you'd like to contribute, then you're most welcome.
Thank you very much. We're going to send a follow-up email with the recording, and you could find Savio's contacts there as well in case.
Yeah.
All right, next question. Do you have any favorite events for students in Tartu?
Oh yes, I like the pancake mornings that happen during the student days. You get free pancakes to eat, and well, yeah, thanks for who organizes it. I've never found the organizers in all this time, but the student days are quite nice. They organize a lot of events. Students are free to participate in those events and spend their days in sort of networking and working on the working in teams. Actually, that's a very nice place to know other people around as well. So yes, events for students, definitely student days in that entire week is quite nice.
Thank you. Okay, let's take this question. What are some of other companies you mentioned that offer job opportunities?
Yeah, Estonia is quite diverse with the companies that are currently running here. There are companies like Milram Robotics doing a lot of robotics related activities. A lot of their offers and job opportunities are there online. There's Starship, Cleveron, many other companies that are actively also looking out for people who can contribute positively to their organization. So yeah, even if you just search companies in Estonia, most of them are quite active and relevant in the fields that are usually like in IT or in robotics and also space technology. But otherwise, yeah, and being a very digital country, Estonia has many things up to date on the internet. So yeah, feel free to look out for them.
Okay. And then our last question gonna be, what skills or knowledge did you learn throughout the program that you found the most useful in your career?
I would say I came here with some basic knowledge of programming and physics. During the course, I of course did a lot of robotics, and that's what the course also required us to do. But I would say learning the aspects of scientific programming and programming languages like Python and R, these are the ones which are quite relevant in my field as well. They have been quite useful. Other technologies like computer vision and yeah, I would say specifically scientific programming has been quite useful so far for me. Yeah.
Thank you very much, Savio, for your wonderful talk. Thank you, everyone, for joining us today. Before we wrap up this session, I would like to remind you that if you are interested to apply to master's programs in robotics and computer engineering, the application period has already started and you can apply before March 15, so don't forget to submit your application in time. If you have any questions, specific questions regarding the program, we are going to host virtual meetings with program directors, and we are going to send you more information over the follow-up email, along with the recording of this webinar and other information. So that would be it from my side. Thank you so much, everyone, and I hope to see you in Tartu one day.